Hi everyone, I am currently looking at page 15 in your 1B packet, part 1. So today we are going to be looking at type 5, which is factoring polynomials of higher degree with synthetic division. So think back to 1A, we learned synthetic division and we're going to be using it as a tool to factor today. So the example you see here is 5x cubed plus 18x squared plus 7x minus 6. Now you have all seen an example like this before, and in the past, I told you whenever you see 4 terms, you're gonna factor by grouping. So we would underline the front 2 and underline the back 2. The problem with this strategy for this example is that if you were to take out the GCF here, it would be x squared, and you'd be left with 5x plus 18. And the GCF in the back 2 would be 1, and you'd be left with 7x minus 6. So you would not have the twins. And if you don't have the twins, you can't take it any further than there. So when you cannot factor by grouping, you need to use division to factor out or to take out one of the factors and then factor what's left. So I've already prepared this on Desmos to show you what this looks like on a graph. Now, in normal times, we'd all have graphing calculators in front of us, and we would plug this into the graphing calculator and find the zeros. You really just need to find 1 0. So I see this one nice right here, and I'm going to write that down on my paper. The 0 is -3, 0. Now, if you have the packet in front of you, you can circle that on your page, and we're going to just use that. So in order to find these zeros using Desmos, you're basically just looking at where they cross the x-axis, but you have to plug it in properly into the calculator. So I'm going to go back to my page and start to do my work. So I know that a 0 is at -3, 0. Now let's see, from unit 0C, when we factored and solved to find solutions of a linear quadratic, we found that if there was a 0 at -3, at x equals -3, it's coming from a factor of x plus 3. In the same right, just a random example off on the side, if the factor is x minus 2, then the 0 is 2, 0. Remember, that came from being opposite. So if it's -2, we got a 2. If it's x plus 3, we got a -3. So this is actually coming in handy in synthetic division. If the factor is x plus 3, what goes in the box is -3. So for the sake of this, you can think of whatever the 0 is goes in the box. So the 0 that I'm using is -3. -3 is in the box. So I'm going to divide by this factor to see what's left. So 5, 18, 7, -6. Bring down the 5. This is -15, 3, -9, -2, 6, and then I end in 0. One thing that's really important when you're using synthetic division like this, because I know that -3 is a root, I know that x plus 3 has to be a factor. So if I don't get 0 as a remainder right here, I know I probably did something wrong. Maybe I chose a wrong 0 that doesn't actually exist. Or maybe I did something wrong in synthetic division. But you should always get a 0 as your remainder when you're dividing by something that you know is a factor. So from this, when I divide by x plus 3, I put -3 in the box, and I got 5x squared plus 3x minus 2. So this is what I get as a result. This is my quotient. But this tells me that x plus 3 times 5x squared plus 3x minus 2 is equal to 5x cubed plus 18x squared plus 7x minus 6. The negative 3 is making a reappearance as a factor, x plus 3 below. So I know that these two multiplied together give me back the original. So just to say that in a different way, I took the original function, I divided by a factor of x plus 3, and I got a result of 5x squared plus 3x minus 2. Therefore, 5x squared plus 3x minus 2 times x plus 3 would get me back to the start. So this currently is like a midway point in your factoring right now. So from here, I'm going to take this trinomial and I'm going to factor just as you've always done since Algebra 1. So I've got 5x squared plus 3x minus 2. So this gives me negative 10. And I'm going to split the middle term into 2 and 5 with a positive 5 and a negative 2. Out of the front 2, I can take out x. Out of the back 2, I can just take out 1. So I have x times 5x minus 2 plus 1 times 5x minus 2. And so this here factors into 5x minus 2 times x plus 1. But that's just this part. And I now need to incorporate the x plus 3 again. So my fully factored version is x plus 3 times 5x minus 2 times x plus 1. So I graphed it on my graphing technology. I use Desmos, but maybe you use a graphing calculator. I found 1, 0. 1, 0. I found negative 3, 0. Then I used that and I divided by the factor that would be created by. So if negative 3 is the 0, x plus 3 is what I'm dividing by. And so negative 3 went in the box. I divided and I got 5x squared plus 3x minus 2. And then I factored that trinomial and I got 5x minus 2 times x plus 1. And I reincorporated the x plus 3. So I have 3 total factors in the end. So this is an example of factoring using synthetic division as a tool. And you do this when you cannot factor by grouping and you have the 4 terms.